This is a modulus question, as you can see from the diagram. It says figure 2 shows a sketch of part of the graph y equals f of x. It tells us f of x here. So two lots of the modulus of 3 minus x plus 5. It also tells us the domain, x is bigger than or equal to 0. In part A, we're asked to state the range of f. Let's get started. In a question like this, when it says state, it means the answer is quite obvious. You can't see the marks, but it's worth 1 mark here. So it should be a very quick, put down the answer, move on. I'm going to draw a diagram. So I'm going to copy out the diagram here, like this. We're looking for the range. You've got to understand the range as if you put in a value of x, you get out a value of y. We're looking for the difference between the values of y that you can get. For example, if I put x is equal to 0, I'm going to get this value of y. So this value of y is inside the range. This value of y is inside the range because if we put in this value of x here, we get this value of y out. And that's the minimum value of y that we can get. We can't get this value of y because there's no graph. There's no x value to correspond to it. So that's going to be the minimum value of the range of f of x. The maximum, well, this just keeps going up and up and up and up and up. Just keeps going. It has no end because the domain, which is here, is bigger than or equal to 0, so it just keeps going on to infinity and beyond. So the y value is going to get bigger and bigger and bigger, and it can always be achieved. In other words, the range is going to be f of x is bigger than or equal to whatever this value is here. Okay, we've still not found it. We need a number. The way we can find it is we can reverse engineer the f of x here, so the function. So if you understand the function, it's got a modulus bit, then it's times by 2, and then it added 5. You should know that a modulus function touches the x-axis and then bounces back up like a mirror. So if I draw this dotted line like this, somewhat like this, this would be the graph 2x minus, 2 and then 3 minus x in a modulus. So what's this point here? Well, the only difference is now we have added 5. So added 5 here. So what's the range? Bigger than or equal to 5. I know I spent a lot more than 1 minute discussing that, but that's usually a problem point for students. So the range is, if you can put an x value in to get a y value, that is part of your range. Essentially, anything bigger than that value of y, so anything bigger than 5, is going to be in our range. Okay, 1 mark. Let's do part B. What does part B say? Part B, solve the equation f of x is equal to 1/2 x plus 30. So f of x is equal to 1/2 x plus 30. First thing I'm going to do, I'm just going to write f of x in. 2 modulus, I keep doing that, 3 minus x plus 5 is 1/2 x plus 30. In order to solve an equation like this, you've got to understand that the modulus bit, what's inside, can be positive or negative. You don't know whether this inside is positive or if it's negative. The answer, when you put the modulus signs around it, it's always going to be positive, but the actual inside, you have no idea. So there's two different things that could happen. Number one is this is true, and 3 minus x is positive. If 3 minus x is positive, then 3 minus x is equal to the same as its modulus. If it's positive, the modulus doesn't change. Alternatively, if 3 minus x is negative, then we'd have to do a shimmy and make everything negative inside the modulus like this. So now it can be x minus 3 as I was writing before anyway. If we now solve both sides, we're going to get two values of x. So I'm going to expand these brackets here and here. I'll times everything by 2. Why not? And I'll do the same thing over here. I'll collect some like terms. So I'm going to have 22, bring the 4x over like this. Do the same thing over here. I'm going to bring the x the other way though. I'm going to bring it to this side to get 3x. And that's equal to 60. And then I'm going to minus 60 to get minus 38. Add 2 to get 62. These aren't very nice values of x, personally. But there we go, we get two values of x. If you're paying attention, you know that one of them can't be true. Do you know which one? X cannot be equal to negative because in the domain of the question, it tells us x has to be positive. So as x is always bigger than or equal to 0, that can't be true. So what's the only solution? This. So x is equal to 62 over 3. Okay, part C. In part C, we are told that f of x equals k, where k is some constant, has two distinct roots. What does just the number k represent? Some constant. Well, imagine the graphs y equals 2 or y equals 5. That would look like a horizontal line somewhere on the graph. So imagine it was, say, here. Can you see that this line, this horizontal line, has two intersections, so two roots? Well, that's exactly what we're looking for then. That is one of the values. But if I move the line down to the minimum point, how many intersections are there now? Just uno. If I move the line up here, how many intersections are there? Just the one. So what does that tell us? We have to find the values in between here and here. Otherwise, there's only one solution, or if we're below that very bottom point, there are no solutions. So it's our job to find those two. Okay, let's do it. We know this point is 5, so we know straight away that k has to be bigger than 5. Answer me in the comments, why is k not bigger than or equal to 5? At the top, we've just got to find this coordinate here. Well, that's on the y-axis, isn't it? How do we find that? It should be the y-intercept when x is 0. So x equals 0 implies that f of 0 is 2 lots of 3 minus 0 plus 5. The modulus of 3 is 3 because 3 is already positive. So we get 11. So this point up here is 0, 11. That tells us that k must be less than or equal to 11. And I'm going to put these together to make it look nice. 5 is less than k is less than or equal to 11 as our final answer for part C, which was worth 2 marks. No, wait, we're not done there. We need to state the set of possible values for k. So essentially it's asking in set notation. So what we need to do is we need to take that inequality and we need to put it in squiggly brackets. It's quite easy to do. Squiggle on the end, squiggle on the start. What do you want? You want k, and then a colon. Okay, now we're definitely done. Well, there you have it. That's our modulus question. Here are 2 more if you need a little more practice.